तू YouTube से चेक कर लाइव है YouTube थोड़े दिसतं हां चालेल YouTube चालू कर तुमचा पासवर्ड चेक कर ठीक आहे हॅलो कोण कोण आहात तुम्ही दोघे ठीक आहे ऑडीमध्येच मी पण ऑडीमध्ये झालो ठीक आहे काल माहिती नव्हतं 3 लॅबमध्ये टॅली टाकायचं मग ते टाकलंच नाही तर ती म्हणजे मला माहितीच नाही बघ ना घ्यायसाठी लाईव्ह असतं कुठेतरी आवाज येतो का? डेट असते मी कशी बोलला
Very good morning to everyone. And the branch counselor of IT branch and advisor of Women in Affiliated Group of Society. Consider also to welcome you all to our flagship event OZ on the theme Next Generation Technology. Organized in association with the Department of IT and BS. This symposium theme Digital Technology aims to provide a dynamic exchange of knowledge, experience, and productive networking from the prominent speakers who are industry professionals working on various trending technologies. Today, we have with us Mr. Sridhar Oja, the founder of Ananda Ecosystems and Arniva Energy Solutions, for the session on metaverse. We have our quantum computing, Dr. Anubhuti Purina, the lead architect automation from IBM. Devesh Jagadhar, founder and CEO of Seven Labs, for the session on advanced AI and ChatGPT. And the last but not the least, Mr. Yasir Arafat Sheikh, the founder and CTO Max Software Technologies Private Limited, for security in IoT. Now I would like to brief you about IEEE Real Science Branch. Today we are celebrating the anniversary of IEEE Real Science Branch, which was inaugurated on 26 February 2018. It is one such technical student body of BSIT that is an organizational unit of its direct organization, IEEE, the world's largest technical professional organization that works for advancing technology for humanity. The BSIT takes pride in being one of the very few non-engineering colleges that are associated with this prestigious international organization. On 14 August 2019, the Women in Engineering of IEEE was formed to work on generating support and opportunity for women as they leverage careers in science and technology. Our objective is of grooming and access the resources expected from IEEE, regular and special activities for students to improve their technical knowledge and management skills. IEEE student branch is one of the most active and vibrant student branch of IEEE organization. Currently, we have more than 100 student members who are a part of this body. They are participating in various competitions at national and international level. Few students became an ambassador for many international bodies like extreme coding competition, we have organized various activities like Symposium, seminar, workshops, coding-con, hackathon, industrial visits, panel discussion, various certification courses and competitions under IEEE branch and also with the collaboration with the IEEE competition and the other branches. So every year IEEE members participate in 24 hours international IEEE extreme coding competition and score good ranks. The awareness workshop under IEEE program for 9 to 10 weeks. Here for major for national Symposium and also movement and special mention for school ma'am, Dr. Ruby Keter, and our vice principal for their full evaluation. My sincere thanks goes to all the students for accepting our invitation and for being a part of this school. And I would like to heartily thank the students for their unforgiving response that we see right now for this school. So I end my speech over here, and I think this is a opportunity to welcome you all once again. Next generation technologies. Thank you so much, ma'am. Now I would like to call the vice principal of the SIT.
So, we know the topics are, I think, talk about topics, not just in India, but in Asia. And I must appreciate the entire organizing committee for having selected one such wonderful speaker and experts in these areas, which are of real interest to not just the IT and computing sphere of things, but also the general public. Everybody needs to understand the possibilities of these technologies. And in fact, these technologies are going to have a effect. They talk about metaverse, and we still try to understand the Marvel universe of these five of areas we have creating something called a metaverse, and how does that all really create? Is it all about all these work lives, our social lives, probably that's something other will create in life. Means Dr. A topic which personally we it just mind boggles me. But I hope we get into the realm of computing, we understand. Sure. These are tips of what I suppose it's important to open our minds, or open the window in your concept, which you will then work for and try to get engaged in. And hopefully, motivate you to do something more. Because these are areas, like ChatGPT and how to do the bar and whatever, all the like in papers in the last 15 days or so, with all the successes and failures being highlighted. So, how is it going to impact our influence? How is it going to impact, are people going to be relevant anymore? Or is it ChatGPT for me, for its own? The community are scared. So, after reflection, try to alleviate some of our fears and maybe confirm them, but about what it really means when we go into this advanced stuff. Yeah. With all of these new technologies, one of the things which is most important to understand is self-reality. And we have to say, towards the end of the session today, talk about security in inside our because surrounded by sensors and devices, the government and that personal data, what will happen to our receipt, what will happen to the sanctity of our bedroom conversations. Are we going to be in an area where we are going to be monitored by the government or what? I don't know. Something we really look at and sincerely put our minds. So I must thank the organizers for having, taking such wide area and brought it all together in a single day on a symposium where we will get to, find some insights in these areas. So once again, welcome to all our speakers and welcome to all the participants for the symposium today. It's lovely to see all of you, in the audience. And I'm sure like me, all of you are waiting to hear from our experts and not from me anymore. So let me just hand it back over to the software and get spoken, by the end of the day, share a little more, educated about this process. Thank you.
Thank you so much, sir. I also request Dr. Boydie to address and
I will definitely not waste more time. Being the most non-technical person over here, I feel my entire academic career from the time of my. But we were just having section of coffee there that technology are all around us. The human touch, the human interface, interaction is really very important. The use of technology is if human interaction in the systematic ways during COVID. We are rolling the technology and I had a minimum interactive knowledge. Yeah, I think that one is good. And so we are having for the technical decision college. We have and our PG students there this year have who have this program here and now we are really so our initiative students have taken all of the together. They have display just the of the and I would say of the people straight. The environment really like IT everywhere, technology everywhere. And I think it's kind of new to be that value was the older generation have to go with the flow and take the best out of the institution is the leading institution towards utilizing what is towards following on and making part aware of what is to be good citizens, they become good candidates for a good I can tell also gives an opportunity and exposes the field here for us. Thank you very much for this.
So, Symposium. The very first speaker today is Mr. Chintan Koraswamy. He'll be sharing his growing work on the topic metaverse. So, we have IIT Mumbai, UC Berkeley, and Oxford University. Recently, he also completed the Innovation Technology Commercialization Profession certificate from the Founder Institute in Mumbai. Host the Founder Institute expanded for collaboration and loss, helping them with go-to-market strategy and scaling up their technology. He has worked with 10 schools across the continents and has mentored over 2 million pro entrepreneurs as they launch express. Then an active volunteer at PNI, ITV, TNS, BNS, One Content, Emerging Technology Forum, and working in Azure. He co-founded Albena Energy Solutions, which is gearing up to launch a range of electric vehicles and high-speed charging. And like sir, we appreciate your presence. I'm sure will be inspiring your voices. Thank you, sir. To consider, sir. Thank you so much, ma'am. Thank you so much, sir. So without further ado, let's start with the symposium.
Uh, Thanks, this is my leaders, facilities, and my pleasure to be here and share my views on the topic. Welcome to the next one. That is the become a place of metaverse. How it will help us. I can be this, however, I can think of that is there are many people during their 1 month. That is how we can like I think in fact, there is history and theology of metaverse. What is its use? and security. This means your this private consequences means we were discussing when we were having the talk about it. This is made to measure. This is a great option. Audio, video, on demand, all projector never happens.
Some people say the metaverse will only for money. This is what you all do. Some people say the metaverse will only for money. This is what you all do. And nobody gets to see. You can only do. Further, will be able to practice at the same time. Before laying your hand on the battlefield. Being able to explore a spacecraft is one. But the metaverse is what is so harder than that. In the future, soon you'll be able to take a spacecraft to ancient people. And only one way to do augmented reality, open field testing. And there you'll be able to model traffic that help increase speed. So while the metaverse may be great, the impact will be great.
Say, while the metaverse is version to affect the leader. Understand it. So what is the concept? We have an example of below definitions. Below definitions, nothing difference. So the metaverse is a term used to describe a virtual shared space that users can interact with each other and build objects in a manner it is a virtual shared space. Users can interact with each other. This often happens for young because there is up then the concept of that has been popular and important. Goes made this brand brands 20% movies. But the real advancement is happening right now because rise of previous technology. Ranging from mostly IT, also related to here, see the technology. At the world, this technology, it is becoming possible for us to get better. The potential effect of the metaverse but is constant by that is the extent of planning so for physical economy and for digital economy. It would change the way we can communicate and conduct business. From 2025 we can conduct the metaverse or you may actually conference in metaverse the very next year. We also have significant impact on the economic business jobs of whether the digital economy. Graphic designers in products and sales for the environment process operational engineers every role is integrated in so huge opportunity for all of us. Additionally, the metaverse provide new opportunities for education. Our society, like I mean, this was me and this is a fundamental in this society and our society. Good society is completely technology. The first one is new technology. In Indian society, we love this to clear the technical process. However, there was also this. For example, we love there are any activities that we have more to complete, right? If metaverse becomes more interesting, then there are potential negative impact on mental and social interaction. In the physical world, people think that distributed. There are people who spend 24 hours in metaverse at a stretch. And then researchers are analyzing the changes on their brain and their hormones. Overall, the metaverse is a concept that has potential to revolutionize the way we live content. Technology is going to take negative impact and effect. However, the right use in the right direction and right manner will definitely benefit humans or users. But it is important that we consider the potential consequences and address the issues that arise as it develops. Let us go ahead and have a brief experience evolution. So, the metaverse is purely look at that one. It was a video network. The media was only 3D. Web 2, we were 3D plus IP. Web 3, we would create the right and more digital asset. The media for Web 1 was very text, for Web 2 was interactive, and Web 3 it was very only very monetizing for digital asset. In terms of control, if we can say, Web 1 was decentralized, Web 2 centralized, everything is now back over there. Goes to Twitter or Instagram, but directly to the being become decentralized. Example of Web 1 would be next week. I don't feel my first two logos of this auditorium. Anyone would know what is next week. It is a browser of ancient times where we used to use dial-up models. In one of my talks, I created a mode of dial-up model, and we were discussing for 5 minutes about what this sound is. No one in the audience figure out what of a dial-up model. This is the way we always internet is a very good. And this will be towards the how you your how is that average Indian home as what more than 3 devices which are connected to the internet. Average Indian I'm talking about. Some gigs will have more than that, right? But average Indian has got 3 devices connected. If you look at example of where people use read and write, comment, like, share. But in reality, for monetization of that, people what you can sell it to or you the right for limited usage. I would recommend this audience to have a look at the Articulus life cycle. Every the Articulus has got a simple looking cow and then they not complicated technologies on this cow. And then we actually divide in different stages. So if you look at us all start, then it is the initial phase, then it gets maturity, and then of course it is the understand any of it, but we'll change the word and we also make a switch about the right. Then again, it will go down. Why is it everyone buying that all energies that we people take the grade and then so much already divide as well we going, but as I already said, we will have no and then then it is then it is what should their forms, because what should be standards are, should be then comes the microphone, then we study coordinates are there, we get next to the virtual reality platform or in content education or in gaming platform, and then also the broad view of experience that we get us. It is a technology step. Metaverse is convergence of particular technologies. And here are the metaverse, as we understand, is augmented reality that it is many technologies in metaverse experience. Right from virtual reality to augmented reality, artificial intelligence, machine learning, when you are customized content to the user, blockchains to feedback and then monetize the patterns. IoT devices to capture release gesture commerce, PCI capture the movements of the user, using reconstruction to generate those virtual worlds and then get everything delivered at speed of price. So, just 7 years of practice. I would not use this in the industry fact. However, can just think that right from the infrastructure is the layer, which is the network, the telecom network comes to the this is what I was saying. It takes, that kind of larger planetary positions, auspicious movements to deliver the right. In what would you world? You are right? As a base there, your presence is needed. I guess around 10% of people have experienced virtual reality. Right? So, who can tell me what is the experience? Yeah, बाजू वाले ने हाथ उठा के तो हमने हाथ पहले कैसे पढ़ी सर? Who can narrate your virtual reality experience? Can you set up and narrate your virtual reality experience? What did you do in your yeah. Oh yes, go ahead. Yeah. Yes, narrate their VR experience. One person. Okay, let us hear from them and then we put back in. Please come forward. Thanks for coming forward and sharing the rest. Ravi?
Here, in Worms, and we talk about the temperature. I think Lenovo, there was a compliment. It's at the time had Lenovo. Okay, so the only it was on YouTube. Can you always put of maybe go on $2? So people are you setting better and you know watching right now very fun. Was as the I watched sci-fi video on you know which was first one so that was
Great, thank you so much. Thanks for narrating. So these are initial virtual reality experiences. Right? That's what it's doing us. How many of you know that a location where you can browse content? You know where to browse VR content? Anyone? The most easy is YouTube. YouTube is world's largest VR content. There is a separate channel. Collection of virtual reality channels available on YouTube. Just go ahead and virtual reality YouTube and get the file. Do we have, are we lucky enough today? All right, so let us continue in the meanwhile. Sir, please, if you can, join us here. Sorry for this disturbance. So let us continue in the meanwhile. So we have got Indians are jumping on the bandwagon of the house. I got a collection of slides to show you that how many things are happening in India as far as metaverse is concerned. As I mentioned a couple of minutes ago, because cars in India, as in it is actually it is party, and then when we party about that, popular level parties around, the level man is the first artist to conduct the concert in the house. So the level man is conducted a concert in the house. Someone organized a Christmas party in the house, which was located with American people. So these are the kind of experiences and events that can be conducted. Thank you so much, Manu. So, anyway, so public sector banks, which are in private HDFCs and ICICI of the world. But the public sector bank is in metaverse. Why would they go in metaverse? What was their motivation? Because there are customers who like to bank in metaverse. The Reliance industry is the first company to conduct annual general meeting in metaverse. Because at metaverse today, annual general meeting is one of the first multi-place clearing matters. What kind of multi-place are gone? Because Shiva is some yeah, what metals they are experiencing any reason to get anywhere. Mahindra, Hyundai, our automobile companies were offering their this way of the new electric vehicles in metals. And it is over monthly place in metals. There are documented examples. In fact, forget BCCI, which is stated to be one of the richest sports bodies. Hockey India is in metals. And if you look at the tableau of Ministry of Education this year, for 36 January college, it had from metaverse category on the category set. And with the rise of new education policy, the adoption of metaverse is improved. This let's see what I have to present. So in 2020, in 2021, the metals market was $51 billion across the globe. And in 2020, 2030, just in a decade's time, it is going to be $1.3 billion plus. The CAGR is 44.5%. So every year, almost 50% growth is coming in this domain. What are the advantages of metaverse? Immersive, interactive, virtual experiences. Three keywords: immersive, interactive, and virtual experiences. Increase social connectivity. You can meet friends from different countries, from different cultures. Greater accessibility to education and training. The main challenge in education is how to deliver quality education in urban, semi-urban, and rural areas. Improve ability to conduct a remote work activities. Right now, when you are working, you are playing data in and afterwards, with writing first, we can link the data with the it will also provide us increased ability to create, share, user-generated content. And the way years ago, we had seen a video on YouTube or WhatsApp wherein an artist is trying to generate a painting in film. You can actually with your and here you can create a 3D painting. It will also give an opportunity for people disabilities to get the world in a better. There are a couple of disadvantages as well. Lack of regulation and oversight. And now there is no unified regulator. Ethics issues. Increase the risk of addiction. People will start living in metaverse. Potential misuse. Security, privacy issues. And this job loss, risk of job loss in physical world, while creation of job opportunity in virtual. Increase polarization and polarization of social and political issues. Because in metaverse, a human mind can easily get manipulated. To be shown content which would change your political or social alignment to certain personal parties. It also increases dependence on technology, decrease attention and focus. Right now, our attention span is less than 10 seconds. But we again, this can again decrease the full attention span. Decreased empathy and emotional intelligence. Even the metaverse was thing that we stay to with. is not empathy at all. The emotional intelligence also. People will think that in some machine world and they are there to give a command and things will start happening, which is not possible in physical world. Increased risk of surveillance and censorship. Increased risk of hacking data breaches. So let us see. Private practice is uses for this regard help to understand the rest. So here's basically various information. Here is for most people, they'll try to let you visualize how your PPS is like how your villa would look like. Meaning all of us are familiar with social media. There are social media platforms in virtual reality right now. Just go to Google and search. Probably may be able to reserve your as a user in right now. So there are not only social media platforms which are on the marketplaces where we are able to sell. And I have a video of the show, one very slow on metaverse, wherein the customer, the ladies can actually see the wallet or purse or whatever thing you want to buy in 3D and then make a decision to purchase. So instead of shopping on a token screen, you may be able to visualize the entire shopping, whatever you do with 3D and then make a decision. Creative arts and design, various arts, fashion, newly designed, digitally designed clothes, new designs, advertising in metaverse. Having advertising, advertisers can follow various marketing initiatives, marketing companies who can be metaverse, retail because of shopping experiences, sports, gaming, sports, people will play with tennis in metaverse, banking, we just discussed, bank is in metaverse, healthcare and wellness, infrastructure is delivering yoga classes in 2 weeks, then come metaverse. You will have a program in front of you and then you will be doing yoga. Or even Baba. The one of the best use cases in metaverse is manufacturing. Wherein Microsoft HoloLens could help you analyze the status of machine, enhance the machine is generating on your website. Religion. Multiple religious spaces would be available in metaverse. No, various sports discussion would be available in metaverse. Travel and hospitality. Swiss tourism is already set holidays in Swiss Alps. Entertainment, Bahubali, Bahubali in metaverse. Check out YouTube, it's already there. Virtual collaboration. Collaboration spaces like Viva will be available in metaverse. I've got a couple of videos to share, but in the interest of time, we'll skip it. Telecom operators will be using metaverse for analyzing their data and the network infrastructure. Various construction companies, real estate companies will be using metaverse, creating digital twin and then making best use of it. In agriculture, metaverse is used to train farmers. Defense forces are using metaverse without firing a bullet. They are training soldiers to manage civil defense. So because the schema is metaverse. Airtel has become India's first telco to launch multiplexing metaverse. A collection of news items which are already available to public domain. So it's not just me. All of you are seeing these news items either on internet or in the newspaper.
I really what is this for this maybe forward let me just mention that our technical team, the students' technical team, as well as our college technical team, was working till yesterday, very late evening, and they are before going home, they saw it was all right. And now that is technology. Okay, so we have and now they are feeling back for all that. I would say that it is everything is not planned. Only thing is we should have a plan B ready. Okay, and that also shows the students how difficult it is for the teachers who are coming and teaching you here, like today it was for us. That something goes wrong, they come with a good presentation and it's actually something goes wrong. And then you think that how the lectures are there and what is happening. But now you know that everything is not in our hands. So I really apologize. We will shorten this to the book. It will be also there. Please bear with us.
I'm sorry.
Yeah, go and put, explain what you have.
Sir, am I audible to you, sir?
Yes, Dr. Sarika, I'm able to hear you.
Sir,
Are you able to hear
just
me?
make him, make sir host. एक बार host करो, sir. Sir, am I audible to you?
Yes, I am able to hear you. I hope you guys are
Yes,
able to hear
I
me
think
too.
you can see us also.
I can see the screen. Yes.
Yes. Okay, sir. And you can hear us also, right, sir?
Yes. I can hear you clearly.
Yeah.
Yes.
So we'll just make you host, so you can share your screen. So we'll just अपना वो start कर दें. Share करो पहले screen सर का. सर का start करो. हाँ, एक बार सर को host बना.
All right. I should be able to start.
Yes, sir. Yes, sir.
Screen
Just
share.
start.
Okay.
Yeah. So just one sec. We'll
Yeah.
just introduce you, sir. Yeah, you are the co-host. Start.
So,
Sir.
So,
Yes. Please go ahead. Are you able to hear me? Okay. All right. So thanks a lot. I know technical glitches are the norm nowadays. So thanks for everybody's patience. My apologies. I could not be there amongst you in person. My name is Anbu, as I was introduced. So today I'll be donning the hat of what we call as a quantum ambassador. And when we think about future of how technology is evolving, there are multiple dimensions to it. What you might have recently seen is this chat GPT, which we in general call big AI models. That has a large corpus of knowledge from where it can draw upon. While innovations happen in those areas, better algorithms.
So you are not audible.
so you are not
Hello. I am not able to hear anything from you guys either. All right, so I guess I'm audible now, right? Okay, so let's get started again. Hopefully, second time is the charm. Let me share my screen.
Yeah.
All right. So as I was just talking about, while a lot of technological progresses are happening, the progress needs to happen in multiple dimensions, parameters. One such dimension is what if the classical way in which we are building computers itself could be changed. Today, we rely on electrons, microprocessors, and the various gates, and our understanding of how bits can be transmitted across various stratum is the definition of what computer is. Quantum is one such change which changes the fundamentals of how we think about computers. So what I'll take you folks through is probably the next half an hour or so. I'll talk about why do we need such a paradigm shift in computers also, while we have fantastic innovations related to artificial intelligence, more modern algorithms, and many such things happening. Why do we still need to change the computing paradigm itself? We'll talk about that, then how real that change is, and more importantly, what can each and every one of you do to be part of that quantum revolution, right? So let's get started. All right. So it's nothing new. I just want to say this, right? While the world may seem like a big place, in the magnitude of the universe, we are just a small planet. But we have so many huge problems to solve. What do I mean? Right? With overpopulation comes challenges on whether we have sufficient crops, sufficient food to feed. How is our energy generation, our reliance on petrochemicals and many other, non-replenishable, non-renewable resources? How is that going to affect us? What are we going to do with, housing people, coming up with smarter cities, more condensed living spaces, and so forth? And how are we going to tackle the new age challenges related to germs and microbes? And so recently, right, we had COVID. Each of this require innovations that is beyond the current classic computing paradigm. For example, if we need to come up with less biosensitive, what I mean by biosensitive, less ecologically disruptive, but better at bonding nitrogen to the soil and not wait for the usual natural cycle. Today, with the classic computers, it's almost impossible to synthesize a molecule or a chemical that can achieve this. Likewise, every aspect of our existence has huge problems. And that's what is the context in which we start thinking about what more is required beyond investments in advanced artificial intelligence and algorithms. So our mission from IBM, for whom I'm the quantum ambassador, we want to bring useful quantum computing to the world, and more importantly, make the world quantum safe, right? Bringing in a new type of computing. You might have read in many news articles that had been flooding the internet over the last 2 or 3 years, that almost everything in our internet and our IT systems are based on encryption algorithms that relies on the difficulty of the classical computers to compute prime numbers, right? And if you come up with a sufficiently large prime number, and if you use that to base your algorithm on, it's practically not crackable by any of the classic computers. But quantum just makes it easier to crack any such encryption algorithms. So our commitment is also to make the world quantum safe, irrespective of the existing systems that will be compromised. But quantum also brings in new challenges, and let's look at a few of them. Okay. So it's not just IBM who's thinking about it. One of the great minds of 20th century, Dr. Richard Feynman, actually, talked about our inability to represent what we call as real universe nature related problems in computers, because we try to reduce that to bits, which has two states. And if we try to represent a complex state, let's say of a molecule's thermal state, you probably need something like 10 to the power of 48 bits to simultaneously represent all the states of that molecule, right? So it's not easable, it's not tenable to use that type of a system. So he had theorized that in his Simulating Physics with Computer publication back in 1981, that why not a universal computer that is based on something other than bits be explored. And quantum is one such theory that he had proposed at that point in time. So this has been in the minds of physicists for over 30, 40 years, 50 years. But to make it real required a lot of technical advances. And when it became real is in 2017, when we were able to break through the barrier to simulate each and every quantum states and control the transitions of quantum states. Okay, so that's what was the start of the quantum computing. If we at a later stage we look back at the history of quantum computers, 2017 to 19 is probably where we start looking at that. So clearly, universal quantum simulators, right? Maybe we cannot do the classical physics way of how quantum computing works, but we can simulate how quantum computers are supposed to operate. And if we are able to control that, is probably a great way to get started. And that's how IBM has started. Yeah. So let's talk about the problems earlier, right? So what I'm showing you is a supercomputer. This is the 5th fastest supercomputer as of today, right? And when it was introduced back in 2019, it was, I think, in the top 2. It's called the Summit supercomputer, built by IBM. It's got 9,200 Power 9 processors. Each of this will have many more cores and over 27,000 GPUs. And it can perform 200 quadrillion calculations per second, right? So if you think about it, the number of floating point operations, flops, that we count upon has increased dramatically. Even our laptops and desktop computers can probably reach teraflops, easily gigaflops, which means we are looking at extreme capabilities of supercomputers. And it can simultaneously store 250 petabytes of data. Isn't that enough to solve problems, right? Why can't we solve all the problems that we are currently facing with such a powerful computer? And there are more powerful computers also. There are 4 more powerful than this, right? So there are still intractable problems. That's what we are trying to say. So if you look at the problems that we have in the world, right in the middle is the problems that we can address today classically. It's a subset of the problems that we hope we can address with a combination of quantum and classical computing, right? And if you look at this, there is problems that we know today, which is in the light blue, that we can't address adequately today. But with combining quantum computing, we also hope that we will come up with new opportunities for doing the problems, right? Tackling the problems that we may anticipate. For example, today's problem is not space exploration. Maybe with quantum computing, those things becomes possible. So that's how we look at the world, that we can solve some problems, we cannot solve some problems. Quantum is not the answer to solve all the problems, but it is going to solve more than what we can classically solve today, and maybe open up new opportunities that we haven't thought of. Right? And one of the fundamental changes required is to go away from bits, right? Zeros and ones. They're really very useful, right? But then this is useful if you have to, let us say, multiply two large numbers. Our computers can do in quite fast, right? It's extremely fast for that. But if you have to factorize a very large prime number, or find out whether a very large number is prime, it takes a long time for the classical computers to do. So that's a limit of bits. So clearly, the future cannot be bound by just ones and zeros, right? So that's what we are thinking about. And hence, if you have a bit and you can create a classic logical circuit with ANDs and XORs and so forth, right? What would be the future would be to have a quantum bit or a qubit, as we call it. Qubits are where the states are not defined as 0 or 1, right? It can be 0 and 1 simultaneously. It's really a strange way to make a statement. How can something be 0 and 1 simultaneously? That's the fundamentals of quantum physics. And maybe that's something that you can look up in the internet on. But what if simultaneously both states can exist, and based on certain conditions that you define in your algorithms, the probability of observing a 0 versus a probability of observing 1 is discerned or delayed right up to the point of observation. That's really what quantum computing allows you to do, which means if a single qubit can simultaneously represent more than one state, then your scale becomes much more possible. So if you need 2 to the power of 64 bits to represent a particular piece of information, then 64 qubits is sufficient to represent the same information. So you can see the order of magnitude in reduction of complexity, right? And obviously, this also requires what we need, what we call as the quantum circuits and quantum gates, like a H gate and an X gate and so forth. And I'll be sharing references through Dr. Sarika to all of you. You can read upon these fundamentals. So this changes how we look at, how we calculate, how we manipulate bits to qubits. But otherwise, it's the concepts are similar, right? Instead of a bit, you have a qubit. Instead of your classical AND and XOR gates, you have the H gates and X gates and so forth. That's what I hope would make it interesting for you. So we do believe these types of quantum computers will solve 3 major areas almost immediately, because we are seeing a lot of customers already signing up to solve these things. So we want to simulate real life natural systems like chemistry, material science, and high energy physics systems. You want to represent them in computers and use the simulations. Simulating them as quantum systems is probably going to be more tenable with quantum computers. Similarly, today we use various tricks or optimization steps to reduce the complexity of, for example, when we are training a model or when we are doing pattern recognition. We look at shortcuts so that we can arrive at the convergence point sooner. And these types of manipulations, mathematical manipulations, may not be required. We can cover the entire search area when we are doing, AI model training, if that's what you are. Similarly, if you're looking at the finance industry or any type of optimization problem, especially multi-objective optimization problems, today we'll have to use this trick called Monte Carlo trick. Many of you may be aware. So we probably don't need to. Risk analysis can actually look at more variables, more dimensions, and our optimization can probably optimize on many more aspects than today is possible, right? So these are the type of use cases that we are looking to apply quantum computing on. And if I make it more real, right? What does it mean, right? So if you are able to simulate the real chemical systems, maybe we can come up with improved battery materials instead of just the lithium-ion batteries that we currently have. Maybe we are able to identify manufacturing defects. So Defects in manufacturing could be a thing of past, and so many more, right? High energy physics classifications, financial offer recommendations, credit asset scoring to risk analysis, and there are many others, right? If you have to do a freight forecasting in a global supply chain with many variables, it's impossible to say when you will have a lack or a shortage of something. Not too long ago, because of COVID, supply chains got disrupted, suddenly had battery issues, and the chip issues, which is affecting, let's say, the Maruti cars from getting manufactured, so many other things. And it's surprising that in the new information age, we still come up with these problems, right? We are faced with these problems. And better forecasting requires better computing technologies, and quantum is one answer for it, right? And it's not that we are having theoretical problems that only IBM is solving, right? It's actually real, right? We're solving materials discovery with Mercedes-Benz, better tool for chemical and engineering to see, how we can recover hydrocarbons with ExxonMobil, and this freight routing, maritime routing, again with ExxonMobil, better finance predictions for JP Morgan Chase, and even looking to understand how the universe works, right? What types of particles are still hidden, what type of theoretical constructs to explain the universe using the CERN reactor, right? It's also a partnership that IBM is applying quantum for. So this is real, and it's across many such examples that we have. And this is probably the time to get on to skilling up on quantum computing if you want to be part of the research and application for the future. So what's the path towards quantum computing, right? We believe that for computational advantage of quantum, we need all the aspects of quantum to be we should be able to perform this in an efficient, cost-effective, and accurate manner. Number one, right? The quantum computer should be reliable in that way. And we also believe it needs to happen alongside classical computers, right? And while we say that it cannot be computed on classical computers alone, it's also true, at least in the interim, for quantum computers also. Because many of the information exists in storage technologies that uses the current classical way of computing, and it's geared towards that. Even the magnetic imprints in, however, compressed the solid state drives are, it still is more suitable for bits, right, zeros and ones, than the quantum qubits, right? So all of this needs to be considered, right? So for us to advance quantum computing, the value that we are talking about involves the performance that we can achieve with quantum computing, making the entire experience frictionless, and add additional capabilities so that you're able to abstract many of the complexities of quantum computing away, so that a normal IT student or a IT professor can look at it as more a capability that is a black box, and go ahead and start writing models and algorithms around it, right? That's really the value proposition that we are driving towards. So what do we mean by performance, right? Performance should have a different thought process when we look at quantum computing, right? Classical computing, we used to measure it on number of bits, and then later on we started measuring it on the CPU speed. Now nobody talks about CPU speed. We are probably talking about the number of threads and cores and so forth. So what's the equivalent of performance in quantum computing? So we need three things: the number of qubits that it can support. And today, just last year, end of last year, we released something with 422 qubits. Right? The second one is the circuit's fidelity itself, right? Quantum states are hard to maintain. We actually have the quantum computers running close to the absolute zero, right? The minus 275 Kelvin, right? The absolute zero on which the space actually, right? If you go outside of the Earth's atmosphere, that particular temperature, it's pretty close to it, a few degrees into it, which means even a slight movement of a particular atom across the circuit actually changes the state, right? Because there is energy that is emitted during that, which means the circuit's fidelity to hold information for sufficient amount of time is extremely critical. And then we need to lay out the circuit in such a way that you have predictable speed, right? It shouldn't be that the circuit is either going too deep in certain cases and or too shallow in other cases, and it's going to come up with problems where we can't do any parallel processing. So all of these needs to be factored in. So if you look at the number of qubits, as I mentioned, we already have the 433 qubits as the ones that we have released last year, end of last year, and we are on track to achieve 1,000 qubit system this year, right? And we achieved it through innovations where from a single layer to multi-layer layering of these circuits and all, with wiring and separating down the readout stack and many other things are part of this. I know some of this is more electronics oriented, so I'll quickly skip through. So, but the circuit overall, if anyone has looked at the latest, say, Intel or AMD based processors and how each circuit layout is, you'd find the stark contrast that you see for the 433 qubit quantum circuit, right? So just for reference for you. So what do we mean by quality? And what do you mean by circuit speed, right? If you look at it, quality is to make sure we are able to observe the qubits in a state that we intended it to be, right? So the algorithm is meant to actually observe the qubit state. The probability of 0 should be higher than 1, for example. And it turns out that because of various circuit quality, it's a reverse, right? So how do you do error correction? The classical way was to just repeat the quantum algorithms 1,000 times and come up with a better, whatever is the majority, we will go ahead and take with that. But now we are able to come up with better techniques related to that. And how do you, measure speed? And that's what I'm flashing in the screen now. We come up with the measurement called circuit layer operations per second, right? So how many parallel and parameterized quantum operations can a quantum processor unit can execute per unit of time, right? So that's completely different than the floating point operations per second that is used by the quantum computer. Again, I'll provide references to this. You can learn upon that. There are papers that we have published. There are simple YouTube videos you can watch to talk about CLOps. But our intention is to achieve 10,000 CLOps end of last year. But we are happy to say that we've already crossed 15,000, right? So, which means the speed at which the quantum computers is becoming better is much faster than the Moore's law that the classical computer which is following. That Moore's law states that your processing speed will double every a certain unit of time. This seems to be in an exponential rate, not this linear doubling rate alone, right? So this is at a much faster rate. This is coming at us. So these are what makes it practical, right? Quantum computing. But for people like you to use it, it needs to be a frictionless experience. It shouldn't be that you should forget everything that we have taught in an IT course, like what you or many of the students here may be attending. And then you come in and then you'll have to read something else completely different, right? Not that way. So to make it frictionless, there should be circuits and there should be algorithms that are hiding the complexities of these circuits, right? So, and it should be predictive in that particular case. And the primitives that we use for both near real-time quantum and interaction between classical workloads and quantum should also be, simple. Right? You should have a simplified interface. It should be as good as a simple Python program that you run, and that's all we should be caring about. So, looking closer, there are many challenges to achieve what we are talking about. Right? So, you have 3 types of systems: near-time classical system, real-time classical system, and then they all need to interact with quantum systems, right? So we have different libraries through which we achieve this. For real-time systems, we have assembly programming models for quantum. And then for near-time or delayed time type of a classical problems, we have a Qiskit, what we call as a runtime library, which is as good as you can either use Python or Java or whatever is your higher level language. Based on your requirement, you can start with either of those. Okay. And we hide the details of the quantum circuits using that assembly language, but there is a different assembly language that is required. So if you're going to work on compilers for new programming models that would work on quantum computers, you will probably need to work on the QASM library. But if you're just looking at algorithms for data manipulations and optimizations, you can directly start with Qiskit and not worry about the specific circuitry. Right. And so the interaction between classical and quantum computer is what we mean to make it frictionless, right? And hence either you use the Qiskit program or the open QASM 3 circuits, right? And it gets compiled. All of these are available for you to explore. I'll be sharing links for you guys to do it. So then finally, the capabilities. Right? If you look at the capabilities, if you look at the classical circuits that we started off with, there may be some executions which will end up with a circuit that is not completely optimized and may have variable depth based on when you run it, what circuits are available, how your particular workload is scheduled to run within that quantum processor unit. So with dynamic circuits, that is getting solved. And this capability is now available in 18 of our quantum computing systems. All of our quantum computing systems are available on the cloud. And some of them are actually free, right? The free ones are the lower qubit area. But as and when we continue to evolve, more and more capabilities will come. And for educators and researchers, there are additional resources that you can start off with. So dynamic circuit is the other one. So all of these also means that we need the developers who use classical computers should be able to use the same tools, languages, similar programming methodologies, models, algorithms, and you should be able to run it in quantum computers. And that's what we have achieved with the Qiskit runtime. Okay, so we need kernel developers, we need algorithm developers, and then we need model developers. All of these folks together, and many of these needs to come from educational institutions such as yourself. And together is what makes up the developer ecosystem, right? And based on where your interests are, you can start with that layer also, right? And you don't have to know about the details of today you don't need to know about the details of the Linux kernel to execute your data science algorithm. Similar thought process exists for quantum computers also, all right? So just a quick look at the roadmap that we have at this point in time. So you can, as I mentioned, we have already put out the Osprey, which is the 433 qubit system. And we are on target to deliver the 1000 plus qubit system Condor. And you can see the acceleration we are looking at. By the time we are crossing 2025, we are looking at somewhere between a 10K and 100K qubits. And this is when the quantum advantage would be ideally achieved. While the qubits are improving, there are also additional capabilities that are provided for kernel developers, like dynamic circuits was there. What about the credit limiters? What are error suppression and mitigation controls that we can provide? What's equivalent of error correction in quantum computing, and how can kernel developers program around it, right? So all of that will come into picture. And for algorithm developers, you'll get quantum serverless. What about intelligent orchestration for you to execute multiple tasks parallelly? How do you branch and merge back, and many other things will come in picture, right? So all of this together would be made available over the next 2-3 years. That's our roadmap. So I will skip over some of this, but why is it relevant for India? Right? Just last year, towards 2021, IBM announced that with Indian Institute of Science and the various IITs, right, including the IISER in Pune, IISER in Thiruvananthapuram, and IITs and IIITs formed a consortium where you can provide access to quantum computers and assist in teaching courses. Last year, we actually signed up a memorandum of understanding with IIT Madras to use quantum computers to solve some of the intractable problems together, right, for research purposes. So, which means quantum computing as a research tool and an educational tool is already being explored by premium institutes around our country. And I hopefully, it will become more pervasive and more of you will get into this. Right. Okay, so we do believe, and this is a playbook that was published not too long ago, we do believe this is probably the quantum decade. By the end of this decade, quantum computing would become more and more pervasive, that we'll start accepting it as an equivalent or a complementary or a superior based on where we end up in that journey of the classical computers. Okay, so what can you do? I request each and every one of you to learn more about this Qiskit and IBM Quantum. And there are many other quantum technologies out there. You can take a look at each one of them. To learn Qiskit, anybody who is a programmer at heart, just go ahead and pick up this free Qiskit textbook that is available with O'Reilly Publications. You can go ahead with that. And then you can go and join the quantum computing experience and try the simulators that are available, and also run a few of your programs in the quantum computer itself. And once you have gotten familiar, this is one of the first times that we are offering. You can get quantum developer certified. Now, maybe in the resume it may not make sense immediately, but this is at the beginning, right? So which means you get to know how quantum computers work, inside the box, inside under the hood. And that way, when later on, when the quantum computing matures as a market, we'll be in a better state. Right? And if you're more into light reading type of a thing, you can watch the Qiskit YouTubes also. But more importantly, there is a researcher educator program, and that's something that I can work with each one of you. So if you are interested in incorporating some parts of this quantum computing into your learning program, right, as part of your syllabus, right? Some of these are also provided, and there's a link that I'll share through Dr. Sarika. You can explore that and directly apply to that and see if this can be part of your curriculum at a logical point in time. So that's the length and breadth of what I wanted to cover, and there's a bunch of resources that I'll be sharing across. I know due to technical difficulties, we had to cut short the talk a little bit. I just wanted to give at least 5 minutes or 10 minutes for anyone who has any questions, so that I can address them live. So I'll stop at this point in time. Thanks a lot. Wonderful meeting all of you over Zoom. And if you have any questions, let me know. And Dr. Sarika, I know I was talking. I didn't see any other messages. Hopefully it was audible throughout. That's an excellent question. The number one is actually effect that quantum computing comes. One of the first effects is the risk that it poses to current cryptographic capabilities, and our reliance on the difficulty of classical computers to do certain operations is no longer the limits. Right? So what IBM has already invested in fact, IBM has joined the US NIST program to make all the existing systems quantum safe. What we mean by quantum safe, the cryptographic algorithms, how can we update it? What type of new algorithms can we come up with For example, a lattice-based cryptographic algorithm is now, experimented with. It's proven to probably challenge, some classes of quantum computers, right? The similar type of exploration is already undertaken with the United States government to come up with better cryptographic algorithms that would be difficult for both classical and quantum computers to break. So yes, there's going to be a huge impact, right? Everything, for example, if you're using internet and you're using a TLS certificate, and you're hoping that the password that you typed in your Netflix or your Flipkart account is not seen by anybody else, well, quantum computer can start seeing it, right? Because it can actually break that cryptography because it can come up with the right prime number in probably a matter of minutes compared to years that it takes classical computers. So there is a huge impact, but there is already effort underway to protect the systems, and there are new algorithms being developed. Yeah, the limits, primary limits is some of this is short term, some of this could be long term also. The short term limits are the following. The energy levels that is expected to come up with the quantum, type of an experience, right? Quantum requires what we call as entanglement, what we call as superposition. These are concepts that everybody can learn upon. But in a simple manner, superposition is what I talked about, a particular state of a qubit being simultaneously 0 and 1. And based on the calculations that you can actually simultaneously perform for both 0 and 1 of that qubit, and progressively that superposition is maintained. For that to happen, a specific temperature is required and a lot of cooling systems are required. Its energy that is required to run that is probably equivalent of an entire factory, right? So there's a lot of energy consumption. There is challenges in maintaining these quantum states, and to achieve entanglement, we have to also keep things separate. So that is the short-term challenge, right? How can we create quantum computers that are stable in higher temperatures so that you don't need this super cooled computing area? That's one. Second is, most of our workload, information, and people skills are in classical computing. When a new computing paradigm comes, the first thing that is required is to seamlessly work alongside the older computer paradigm. If you think of an analogy, when Uber and Ola came in, right, it still used the cars that were used by the taxi people, right? So, but then it opened up how it interacts with it. So we have a challenge on how we are going to make the classical world interact with the quantum world. Quantum world can do things fast. Quantum world cannot transfer information out of its system back to the classical world in a fast manner. We still have a challenge there. So how do we convert classical information into quantum computable information and back to classical information? Because that's where we are currently. So those are probably two current major hurdles that we need to overcome. The other one is, we still don't, this is the long-term one. Do we understand quantum physics properly, right? Do we even have the right theories to explain how quantum physics, how entanglement happens and so forth? So we don't know what is the limits of this type of a computing. If you think about electrons moving across stratum and we come up with, chips which are 5 nanometer chips, 2 nanometer chips, we are soon approaching the dimensions in which the atoms themselves are, right? We know that once we get to the dimensions of the atoms, there is a limit to what you can do, how reliably electrons can be, expected to cross over the, the boundaries, right? All of this is, we know those limitations. What are those limitations in quantum? Requires a lot more exploration, a lot more theoretical physics explorations to identify. Today, we are in maybe, I don't know, maybe we are in halfway stage or nascent stage even. So that's probably the long-term concern related to quantum.
for this insightful session that you gave us. I request Dr. Sarika ma'am to give that time.
So it was a great privilege and honor to have you here about us as a resource person on the topic quantum computing and the symposium on the next generation technology organized by Department of IT, MBS and ITS at the student branch. We really appreciate your efforts in conducting the session. Thank you so much for spending your time, valuable time, sharing knowledge with our students and faculty as well. And we hope to have your support for our future and your years as well. Thank you so much and also for joining us.
Thank you for the hospitality. I know you had to accommodate my remote presence also, and hopefully next time I will be in person and will be amongst all of you. And all the very best for the symposium. Thank you. Thanks for having me.
Devesh around of Seri Labs Private Limited, a partner working on artificial intelligence. His major area of work is applying AI, solve real-world problems. He has a good understanding of various emerging technologies. He is actively working with colleges and students to master new technologies, especially data science. He has written many papers, articles, and individual science. He was successful. He has spoken on a number of so I request Vice Principal sir to few minutes. So, so whoever answers so very first one. The options are Puma, Converse, and yeah, it's the so when you get to the big yeah, like three one. Okay. Now the second question is which of these are the better platforms? First is Telegram, second is all of these are. Oh, so let's go on. Which of these Indian companies are providing better so one question now. What? Nice. This part I really hope everyone knows. Anyway, there's a point. The next question is, what is the running charging? Yes. Yeah, okay, so 3, 2, 1. Okay, that's the correct answer. Have your eyes, please, you have to iterate them. Okay, so the next question is of Oprah. And then once Mark Zuckerberg, Sam Altman. That's the options. I mean the options. We'll have. But orange, so you will have to know. Last row. So, please stay.
अभी और कौन सी कॉल है
Very well, here. The next. Everyone else? Yes. Where? What do you like? What? This one.
Stranger better stranger
Let's examine. Here.
I got it. Ready. Mobile लेके चला के मेरे को कोई फर्क नहीं पड़ता उसको घर से फोन आया कि ट्राई पे मोदी का फोन आया कोई फर्क नहीं पड़ता
Yes. Yes. What like? Here is a hand post.
बोलेंगे बाद में देखूंगा कैसे बताओ एक एक करते एक जाओ दुकान दे एक एक आया रहता है किसका कौन सा हैंडल का क्या है पीएलडीएस का हो गया वो 12 बजे खत्म है 12 का चालू कौन सा कोड है नहीं खत्म हो गया 12 बजे तक ही है अभी नहीं ये तो उसका चाहिए session. Is there 3 months old? What? Actually, all going check. Was others in class. Said sufficient advanced hours. It is usable for that. In other words, when it goes to advance, feels like life. And it also feels like
Can you help? Yeah. You. You are aware that we have now come up with a paid version. Yes. About $20. So what I'm using
At the software, yeah.
now we are ready. There is a long waiting list. Still have a need to be built. Can you help me to plan it? Of course. Can you help me to Switzerland can be installed? Can we say, we can visit Germany, so on. And then you can actually go asking. Suppose I want to go to from the state to this place, okay, and you can keep talking to us. So that's another thing. Just giving you a few examples before going on. This right way, how many people want to study abroad after this? Okay. So let's see if we can help us to write an EDOR. What is an EDOR? Let me try a little different. I don't know where this is go. Graduate school. Right? But it can also help to write an actual serial. So it says, I'm sorry. But there are ways, amount. This not Now I ask it, and you say that I'm going to as a this may be because of take. So it's not that you say this is the responsibility that we can just already. When you're writing code, what you're talking, right? Let's try. Please, how many of you know? to check. This is a common code for checking whether it's a valid password. To check whether string contains letters, numbers, question. Explaining. Let's go there. So here, let's show you how ChatGPT can generate articles, can help you to make can write a recommendation to you and you can generate more. So what to be true, right? And obviously, it have a text. And obviously, with this kind of capability, we can see two types of things. We are reading of or watching videos. On one side, people really are angry. They want to find out what kind of use cases. I get so many conversations, people from industry, and they say, how can we use this? What are the ways our industry can utilize the capability of that? On the other side are these questions of fear, will it be better than humans, will it take over things, and our jobs are at risk, we are at risk. So, but one thing is sure, it definitely has a potential to change the way information is organized. When Google started in 1998, they had this mission that they want to change the way world's information is organized. And after 25 years, I think the cycle has turned, and here is another company, another program. But I asked Benji, organize the world. You said there is no one entity that organizes this. There are such entities like Google and Twitter, and there are museums, institutes, and all these people who organize. And can I ask, will ChatGPT change the way information is organized? Then the usual defensive stand of that. As an AI language model, I cannot really change the way information is organized, but I can do this, I can do this, I can do this. In other words, yes, I can be organized. I don't know to say everything, otherwise I think okay. So one thing I want to do, and this is the important part of my talk. Then we'll follow certain slides about limitations and progress. Which, if you think the time is overshooting, you can skip it or take it as part of questions. But this is the part that I really want to do that. Remember, ChatGPT is very new. I have never spoken about this topic. I have spoken on neural networks, but I have not spoken about ChatGPT. But this is something that I want to do well to us. One is that, of course, we tell you that there is no magic. It's just the AI model that actually falls off. The second thing, what I like, now you are in your first year or you are doing your advanced graduation. You are going to join the industry. Okay? You are looking forward to your test. I think 2 or 3 years of time. Large language models, LLMs, going to be very important. They are going to be everywhere. And many of you will probably participate in some way towards this development. So I at least want to leave you with curiosity and interest about what language models are. That's the thing that I want to achieve. So chatting with the chatbot, you know many other chatbots, right? You can use them and banks and you can chatbot. But the way chatbots work is very different from how chat. And that I think is a good starting point to understand how ChatGPT does what you are saying. Chatbot basically has two components. Okay, the first part is intention detection. You can ask anything to a chat, like you said. Like you can ask, you talk to Alex, right? Say, Alex, play, Alex song. There is an engine inside, not in the device, in the cloud, which analyzes the standards and comes up with two things. One is the intention. What do you want to do? You want to play a song, let's say. And two are the parameters. So what song? Like it's saying the parameters. The second part of the chatbot is fulfilling, where depending on the intention, okay, that actually does. Like in this case, it is actually does. This is now chatbots. Chatbots are also based on AI, but that AI is the first box, the detection box. Because people ask the same question in different ways, there may be spelling mistakes, there can be abbreviations, and that's where AI actually tells chatbots to detect what you actually want. Right? But ChatGPT is complicated. It's actually not a question answering answer. It's not a chatbot. But this is something that you should understand clearly. ChatGPT is just a sentence composition program. It's just a word predictor. And word predictors are not new. You have seen word predictor in Gmail. Let's go to my Gmail. And compose a mail to Gmail. The moment I start writing the mail, so that this is happening here. Have you seen this? I'm sure everybody has seen this. Okay. So this is sentence composition, right? It actually suggests the suggesting the next one. It is also called word prediction. This is the same thing that ChatGPT. ChatGPT is a word predictor, which is using its skill in such a way that you feel that your questions are being asked. Right? Let's see how.
कितनी बार आए थे कितनी बार आए थे तीस में
इसके सामने का takes the prompt, then we do planet, we do 7 words, and predicts the next. Or let's say our question is, tell me about IT. So these are tell me about IT, 4 words, words to be the 5th word. Is what ChatGPT tries to write. You want to do that? Let's see what it's like. You are online on the story. When I say tell me about activity, the next word, the first next word is the, and then see, then all, and so on. Now what happens here? When the next word comes out, tell me about activity. The next word that gets added to the original block. And now the block with the block comes the text. See the way how it writes, gives you one word. So that is the effect that's what every time the prompt is getting longer and the information that is coming out is becoming better and better. Because the prompt is longer, so it knows better now what to predict. This is what so. Yeah. If I say tell me more about IT, then I imagine that the first word would be IT. Because usually when we ask this question, the answers are IT means and so now yes, added this is the next stop. But at the same time, it is the output also. And for generating, so next word predictor being used as a question answer. That's what it is. Nothing more than that. Remember. But why it looks like magic? That's something we will see. But for that, for the next word is like we have to go a little into bit of machine learning technology. And typically like that. But still, my lecture is supposed to be strategically advanced here. But obviously, there's no time to get into the advanced. You can leave me for questions or maybe for some other lectures. But let's see how sentence completion system can do so much. So for that, we need to understand how the chat is trained. That's what. Okay. So this system, this model is made up of 2 parts. The first one is called the encoder, the second one is called decoder. Some of you might have studied encoder decoder systems. So for you, it is repetition. But for us, on one side, we put a word. For example, test. Now, encoder is a part of the system which converts this into mathematical representation. One side of going is over percent. Obvious. Other side of mass representation is nothing but a vector for technical students. So you understand. So vector in many dimensions. Large vector cross out. This vector goes into the part called decoder. And another vector cross. That different vector is the next word. Again, we convert it back to words. So, for example, if the goes into the system, both the parts, and what comes out, maybe the words. Yeah. Let's say we are reading the sentence. Best way to predict the future is to create it. Famous sentence said by computer scientist. So we push the when you expect that the network comes out with it comes out with best. But it may or it may not predict that. Most probably it's not going to be that, right? Because we are just beginning. We have an uninitiated network. Have very initial parts. They are not learned. So you can say some strange word. Then we tell the network. No. We want best. Next time we will give the word best. And expect way to come out. But again, that may or may not happen. But we will tell them we want way. You keep doing this, and the network is learning in 3 levels. First is the part what is getting trained is learning. Second, of course, decoder is learning. But the third aspect might miss you. The representation. How words become vectors? What vectors are the best to represent the language? That is the part also getting learned. Okay, so all this learning is happening when you give sentences in this system and say that I push this word, that is the next word that we expect to come out. But I'm missing just one thing. It is not doing a one-to-one learning. It is also remembering all the words that were before. So all the words before the name. And the next. These are the things which are being given to the model, the network, or the system, so that it is not done. And once this is done, then we throw away the encoder. Okay, now what we did just now is not similar. We give a prompt. There is a converter which converts it into vectors, that which we have already decided during our training phase. Then this vector goes to decoder, and decoder now tells us the next. And then we saw the loop. Then the next word gets attached to the prompt. Again, the whole thing goes into this system. Next word. And here are 2 phases of how these models are. In one phase, the networks are given enough data to learn from, which are the sentences, words, and then once the network is properly trained, then we start using it for inference. That is the question answer that we are doing. Okay, so I'm talking about neural networks here only because I want to unravel the mystery why ChatGPT looks like. I have no intention of getting into details of neural networks. Encoder and decoder, which I was just referring as parts, they are actually neural networks. Okay. And this is what neural networks are, what we see here. There are nodes, which are the circles, and there are connections which connect to these. Okay, and we have layers of these things one after the other, so that we have our deep learning neural networks. But more important for us is what happens when the neural network learns. We just said we are going to give sentences, we are going to give words, and so the neural network is learning. This is what is happening. Exactly like our brain. When our brain learns, the connections between neurons get strengthened or weak. In other words, their weights change. So this is what a neural network does by learning. Why is it important? Because if you take a neural network such as this, what it can do, its capacity will depend on how many connections are there. Okay. And this is where the technique of ChatGPT emerges from. In our example network, the first two layers are 6 neurons each, right? So how many connections are there? 6 into 6, that's the second. 6 to 4, that's 24. So totally we have 60 there, right? How many connections ChatGPT has? It's a staggering 175 billion. Indian population is 1.2 billion. Okay, so 1 billion is 100 crores. So this is just too big. And how much data do you think is required to train this kind of? 300 billion tokens. So one token you can say as a one word. Not always, because there will be numbers, there will be a pieces of code and so on, but generally saying token is a word. 300 billion tokens are being trained. And then given to ChatGPT to train. And that's why the magic. So actually, ChatGPT is a child with enormous data. Okay, a child, the way the adult answers the question is that, like I said, if you understand what the question is, think about what should be the answer and give the answer. And it is like a child with the overgrown brain. Okay, it has so much information that you can just keep on talking, thinking about what is the next word I will say, and still the answer comes out to be correct. Not always, I will say. Okay. So I'm just left you 10 minutes, I think I should be able to. So I don't want to talk about all this. I just want to point out the fact that no technology comes out suddenly. Doesn't didn't happen widely. It's a result of a long chain of discovery and innovations that have been happening since the United States when RNA was introduced. But the main invention happened in 2017, where a neural network for transformer. These are all models. GPT. So GPT is based on top of GPT 3.5. GPT 3.5 didn't have question-answering capabilities. They came with instant GPT, which was just January last year. And then they added context to keeping the conversation. That's how chat. So remember this. First of all, ChatGPT doesn't always use the right answer because it doesn't understand what is right and wrong. It is just talking. You know, it's a coincidence that it comes correct. I'll show you an example. And ask about my own problem. In case it doesn't, this happens. In case it doesn't, I'll show you a stored as. I do not know why it happens. First of all, every time you do a different dance, and so you do a dance. Good. Try to read about something new every time. So this is what it says. Today that we are R&D company, founded in 2020. Now it says we are founded in 2006. Even that time it said it headquartered in Bangalore, India, but it is nice to see that we have offices in Singapore and United States. Which reports are coming over there. I don't know. Then giving us a mission which is make AI accessible to business of all sizes. It's not our mission. We don't have a mission. And it is going to give us awards, top 10 AI solution providers in India. Okay. Now, it's giving us some more other things. I would say that we have already done 60. Actually, we have already done and recorded in Bangalore. And I was saying that we have a product called Chatbot Builder. Also giving us a new product called Siri Voice Suite. I do not know what it is. It's learning. And so, as you can see, not only that it's nice, you do not know what they have. Of course, you don't. Then you can read this and you not have a because it has been given information about so many AI startups. They are able to put together such things. So be very careful about, especially this. When people do this for medical advice, then it can be very dangerous. It's not always right. The student conversation, but AI is much beyond conversation. Think about things like image classification and prediction and so on. So it cannot do any of this. So that different networks are required. Not only different networks, remember, AI is not about network or program. So we had a question about what is the language for AI. Because AI is not programming. AI is not programming. Is not programming AI. Language doesn't matter. AI is learning from data. So it's very important. Now, as we have seen, ChatGPT has learned from text. So you have to make it learn with images and whatever else. That is what is term jailbreak. So chatbots are notorious to give objects level answer. So yeah, they don't say secret, they can say things which should not be there and all. This chatbot network put the very around it so that system chatbot overcomes that. Because then it's called a jailbreak. ChatGPT has been given a lot of restrictions by OpenAI. But still, there are people who can prompt it in such a way, not in one prompt, one after the other, so that it can actually start talking in an observational way. There are many examples, but I don't have time to, but very interesting examples you can read about. And then this is the last section. Everybody is worried about this. The students are going to use ChatGPT for homework and assignment. That is a, and we are already thinking because I used to teach a subject in college with lockdown. And so the papers were online. Google Forms. Right? And so students used to take tests and from home, obviously. And I used to take the way. So if I copy an answer and put it into Google, then I can see exactly where it is copied from. Right? So we already seen this that left to themselves, students will take shortcuts. They will use ready-made. Okay, this is not new. Think about the last year projects. How many students actually do those? So, given the opportunity, students will use for but it may be a short-term gain for them, but long-term it's not. Because they are losing the only when it is given an opportunity. If you are not using it, then it will not be creative enough. Which see, ChatGPT is not creating new knowledge. ChatGPT is just giving you knowledge that already exists. When you go into the real world, you will be creating things, new things which did not exist. Right? And so this is where the concern is coming from. Fake generation, I don't know to tell you. I mean, you are using WhatsApp and so many other social media which we spoke about. So fake news is starting new to you, but with this kind of text generation capabilities that can actually explode. Environmental crisis. Right? We saw in the quantum presentation also that some computing can require huge amount of energy. This is not only about running ChatGPT. That I don't think it requires that much. It's the more concerned about training. Training such models actually requires enormous amounts of energy. And since now this is a race, and everybody wants to have their own large language model, the impact on environment can be considerable. That's it. I hope I have finished the time for questions. Yes, but so increasing quantity not really what is not text generation. And even mechanics, there is a huge ecosystem built around generation. Right? So, for example, you have games, multiplayer games, in which you have digital assets, okay, and they are increasingly being generated. You have heard about AI, so we also have heard about LE and stable diffusion, like all these. So these are technologies to generate images. So when you suppose what you do is, in metaverse, in those kind of environments, you can actually write an essay, getting the digital also can say. Right? But you have to write it. But with a generation capability, people can generate digital objects automatically and that is how as for these so first of all, when you say unreliable, it means it cannot be used as an example. It was reported widely where somebody asked ChatGPT that give a document which includes eating glass. Which includes whatever we describe. Also, they were disclaimer that this should be done the advice of the law. So, but obviously, the person who asked is not going to start a diet of eating glass, right? That means that whatever you say, you're not going to use as like you saw about information you about my company. If you are asking about what's happening company, but you have to make sure that it also correlates something else, but just use it as that is one aspect of underlying. But the second aspect is that people might deliver it, and that will change. That is the more serious. And that is where efforts are happening. I think there is a model first which Google is working on, trying to work on. And that is, these are the models where more speed controls are needed. So this is another aspect of the
Also, I agree with that we sometimes, but to overview the company taking the measures or how they are everyone is different from technology. So sometimes but to be with it will be affecting the
yes, so life is also being for your better road. So keep on speaking which are not very good. Now, these papers are obviously, but see, the thing is, every new version of one large language model takes about a year to come out. Takes that much time. But there is no remedy on analysis. And it also depends on what kind of prompt you are using. So that is the same prompt actually is into two different answers. One was day before and one is. And if you ask the same question in a different way, again a different answer. It's not like Google search where you say. So there is not much that can be done about it. That's what I understand. As I said, it's very different. I don't think anybody has that much idea about how exactly things work. So people are using GPT. Is not question and say, but that can also generate text. Long about a year, but this is very new. And so I'm sure as many progresses, these issues will be debated report, and that is where I'll be able to participate from real facts. Today we just not opening. Thank you. Yeah. Hello, sir. You said that very hard. Does been trained on a lot of data. Right? And from that data, what has it learned? So it has learned how things relate to each other. Okay, how words are concepts, right? So how concepts relate to each other. When we talk about one concept, then what is the right thing to say next? And that's why, so in case of code, for example, it becomes very accurate. Because code has that nature, it is a control line. Unlike natural language, code is a control line. And so in case of code, it's pretty much accurate. So, to answer your question, the accuracy, whatever it is, comes out of the enormous amount of knowledge that exists in software. There is no good answer to it. Because ChatGPT is giving you answers with such confidence. And it's answering from such a large knowledge. That we really have to see, carefully. So, see, divide your into two types of. One is the question like, how can I plan my future? Okay, that's not going to be a problem. Okay, because this is a well-known body of knowledge in the world, and people compare and read. Or you ask about, for example, you want to learn about it, if you want to know about it, then it is not okay. But if you're asking a question about, I have a system, what should I do? Only very important. So, first of all, you need to see the concept for your doing. Just getting information, or if you want to get into some action, then you better be careful. And I think one way to follow it, you read about the company, you find one information, but it's the same thing for Google. Okay, important part of the correlation you are going. But what the point that you make that now there are tools which help to detect whether so it's an arms race. Both things are going to happen, but you have to wait and watch as of now. So the things are still being painted.
Yes, absolutely. It was really nice. Thank you so much for what we are not.
Thank you so much. Everybody, principal man, professor, so if you like that, thank you so much for being here.
So now we will continue with our session. 34.
बैग रख के जाओ, वॉशरूम जा सकते हैं, बैग रखे जाओ, बैग रखो इधर ही, बैग रख के जाओ। अभी इसका कोई जगह नहीं है। चलो बैग रख के जाओ उधर, काम ही कर रहा है। चलो बेटा बैठ जाओ। आलू को क्या
So hमारा predicted given variance is against what change here. Let us look at certain advantages and disadvantages. This is because the gap between urban and quality of education. You can only all you do is putting closing. In any and yeah, those people have to protect first. Yeah. So they can only this is what I they can get education, they can get entertainment, they can build teams with other people like us. Greater activity for collaboration, innovation, new things can be developed. There are chemistry that which are being built to the warehouse. So there is no usage of chemical, but people are able to mix two chemicals and observe the reaction of these two chemicals. Potential for increased privacy and security. Privacy and security again, it's an advantage and disadvantage, both sides. You can also have some cultural activities. Generations ago, you can also get a really scientific that experiments. You can also have certain statements and then we have values. You can advantage as well. They have recreation, ethics, polarization, polarization and exposure. these physical activities, attention span and focus. Let's say if you are concentrating, that will build anxiety in our increase awareness and self-trust. Amy, social media, it is advertising, weekly, sports, like other sports. Fitness can really, right? Baba Ramdev or so it's tourism planning, here in our video, which has visualized of Burger store. This store is available in the metaverse. So metaverse store and the here wallet will be included in physical world. Metaverse is also possible. Can you write this? Metaverse. When you close your metaverse, device where all your metaverse for Here are a couple of examples. These are published on Indian newspapers. Not giving anything. Here's these two items. This was published on 2022. The first open and system are being certified. 22. There's was fair to launch 20 days metaverse. 22. That was India Bank of India also launched metaverse. And these are also active websites. Monitoring platforms and screens. 27 and 2023. That's the one is Omniverse. This one was now. Metaverse. 5th January 23, Hyundai launches Hyundai version of Metaverse. Petition 3. Police Arcadian Museum, India's first Metaverse Museum. 23rd January. Ministry of Education. Right. You say this. Parallel digital economy. Whatever you are doing, physical world, it is to be a virtual world. First of all, the kind of interesting videos we have to do. In terms of videos, they are part of it. So, education, remote learning, and so on, education. We do it better and better. So, these are elements. Pushing, what about training? Career fairs, training, executive education, conferences, study abroad programs, and invite students from other countries and then teach them, college schools, industry visits, clubs, organizations like the police sector. Professional development, yes. Portfolio thing, the entire college, mission and space, education, higher education, opportunities. Education. Only include information. Education. Projects. Education and development other education. High education. Like learning methods. Health and education. 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 We strive for education for getting software etc. Education for interest. Then let it on. Which can help best. Social activities to education to entertainment. You can buy or next year. And less than 1,000 rupees for Amazon. It's your mobile phone that's part usually. I like it. And easy on this. Have you connected your LinkedIn? So I will see certain interest group on combining intensive in virtual reality. I was part of one of the SIG where we were actually experimenting the touch part of it. Right? So in Metaverse, I can see the project, but I not understand the program work. Right? So that is the census integration is happening. There are certain experiments where they are trying to integrate smell. So smell is a replicate of through other sensors, gadgets, chemicals, whatever. It will spray certain chemicals so that you have a feel by yourself. You are having your organs in your top parts. Smells cannot easily replicate. One of the is it. So we are able to integrate we able to integrate vision. Now touch is the first and which is getting integrated. Next we please. Go. Thank you so much. Thank you everyone.
To comment out. So, the same question of yes, I think that's a question to come here and to conversely or with
So hey everyone. I hope you all had a great session. Personally, thank you, Visual thank you, and all the facilities of IT department for volunteering. Also, I had special guest speakers for volunteering. Also, I want to thank you all the participants for being here. And then monitoring this collection on Saturday. Since it was a great was here, I was only the us. So that's our back and what I could be meditate and do. I would like to unveil the video of all our events.
We will be participating and for participation, I request Mr. Ma'am, Vice Chancellor, for Dr. Tariq Ma'am, and
Mr. We have three children. Next, we have Vice Chair. Vice Member Secretary. Then Master Aditya Mahandes. Treasurer Tanmay Nirupar. Social media head Mohammed Nawaz and Kabir. Thank you, Sahil. याद है असीता अंदर क्वेश्चन है आपको स्टार्ट करोगे और सही भरी लॉजिक है अरेंज फरवरी जनवरी फरवरी चलाया फरवरी वाइस पर्सन फरवरी सेक्रेटरी
YouTube लाईव्ह बंद करूचा विचार.